For this integral, because the denominator is factorable, I'm going to approach it by using partial fractions. So I want to rewrite my integrand as 1 over x times x minus 1. And then I can break that into the sum of two fractions, a over x and b over x minus 1. Multiply both sides of the equation by x times x minus 1, the common denominator. And on the left, the denominator cancels and I just get 1. And on the right, when I distribute to the a fraction, the x's cancel, so I get a times x minus 1. And then distribute to the b fraction and the x minus 1's cancel, so you get b times x. This equation has to be true for all x's, so choose a couple of convenient x's. So I have 1 equals negative a plus 0b. So that tells me a is negative 1. And then another convenient x would be x equals 1. So plug in 1 and I get 0a plus b. So b is 1. So that means my integral, 1 over x squared minus x dx, can be rewritten as a over x, where a is negative 1, plus b over x minus 1, where b is 1. And then I can integrate term by term. So this becomes negative ln x plus the ln of x minus 1 plus c. Another partial fractions. This time they were nice enough to factor the denominator for us. So I'm going to work on breaking this up using partial fraction decomposition. I have unique linear factors, so each one becomes the denominator of a new fraction with a constant on top. Multiply both sides by the common denominator, and on the left everything cancels and you get 1. On the right, we have a times x plus 2 plus b times x minus 2. Choose some convenient x's like negative 2 and 2. So this is going to be 1 equals 0a minus 4b. So that tells me that b is negative 1/4. And then when I plug in a 2, I get 1 equals 4a plus 0b. So a is positive 1/4. So my integral then can be rewritten as a over x minus 2 plus b over x plus 2. And then I can integrate term by term. So I have 1/4 ln x minus 2 minus 1/4 ln x plus 2 plus c. Another partial fractions where they have factored the denominator for me. So I'm going to try to do a partial fraction decomposition. Each linear factor becomes a denominator with a constant on top. Multiply both sides by the common denominator and I get 1 equals a times x plus 5 plus b times x. If I let x be 0, I get 1 equals 5a plus 0b, which means that a is 1/5. And if I let x be negative 5, I get 1 equals 0a minus 5b, which means that b is negative 1/5. So my integral I can rewrite as a over x, 1/5 over x, plus b over x plus 5, negative 1/5 over x plus 5, dx, and then integrate term by term. So I have 1/5 ln x minus 1/5 ln of x plus 5 plus c.